see there. I was too busy working on my mutation dog. So, what can I help you with today? You want to learn some chemical reactions? Oh, well, I got two that I'm working on right here. Why don't we come show you?
Talking about both reaction nitrogen gas plus hydrogen gas and iron plus copper 2 sulfate. I will first be talking about the types of reactions. I will be talking about word equations. I will be talking about the final product. I will talk about balancing each equation. And I will compare and contrast both reactions.
Okay. To start off here, we have nitrogen gas plus hydrogen gas reacts to make ammonia. So here we have the skeletal equation N2 plus H2 reacts to form NH3, as known as ammonia. Okay, here we have the skeletal equation N2 plus H2 equals NH3. But we're not done yet. We have to do something called balancing chemical equations. To start off here, we have a T-chart labeled left side and right side. So what we're going to do is we're going to label all of the elements on the left side, so the reactant side of the equation, and put them down here. So we have nitrogen and we have hydrogen. So what we're next going to do is go over product side, and we're going to label the exact same elements because of the law of conservation of mass states that an atom cannot be destroyed or created, it can only be moved. So we're going to have the exact same elements on both sides. So now what we're going to do is we're going to label how many elements of that is on each side. So as we look here at the subscript, there's 2 nitrogen. So we're going to write a 2 there. There's also 2 hydrogen, so we're going to write a 2 there. We're going to go back over to the product side, and there's only, as we see, there's only 1 nitrogen on this side. So we're going to write a 1 here, and now there's 3 hydrogens. Okay, so what we're now going to do is we're going to balance out this equation. So we have, on the nitrogen, we have 2 over here and 1 over here. So now we need 2 of these to balance with this. So we're going to cross out the 1, we're going to put a 2 here. So now we're going to go over to this equation, and we're going to write a 2 here. And we're going to look and see what other elements we affected. So we affected the hydrogen. So now there's 2 of H3s. So there's now 6 hydrogens. So we're going to cross out the 3 here, and we're going to put 6. Now we're going to come back over to this side, and we only need 1 nitrogen because they're now balanced out. We need 1 of those. And to get the lowest common multiple of 2 and 6 is 6. So we need 3 of these, 3 hydrogens, H2s, to balance with that. So we're going to cross out 2 and 6. And now we have a balanced equation. We have 2 nitrogens here, 2 nitrogens here. So now we have 6 hydrogens on this side and 6 hydrogens on that side. So now we're fully balanced throughout the entire equation. The way we know that this is synthesis is that we have 1 element here and 1 element here, and they now, during the reaction, they've now bonded together to make a compound. Synthesis is when you have 2 or more elements come together to form 1. We know it's not single displacement or double displacement because they have not replaced anybody, and we know it's not decomposition because we've only have 2 elements and they've come together. They haven't started as that and then moved to that. Okay, so now that we've talked about balancing the chemical equation and the type of reaction that occurs, we're going to show you how to get the final product NH3. So if you look at nitrogen on the periodic table, it's in the 5th column, which means it gains 3 electrons, making a -3 charge. If you look at hydrogen on a periodic table, it's in the 1st column, which means it gives up one of its electrons, giving it a +1 charge. So how do we now get NH3? Well, we have to balance out the chemical equations. So we take this -3 here, and we move it down here. So now we take this +1 and bring it down here. So now this nitrogen needs 3 hydrogens to balance it out. So now you have N1 and then H3. That's how you get your final product, NH3. Okay, so ammonia can be very dangerous and even fatal to humans. We must be very careful when working with it. It is a colorless gas. It can build up in your lungs. It can burn or irritate your skin. It can cause permanent blindness. And over long terms, it will harden your respiratory system, causing many problems in the future. So we must be very careful when working with these. Ammonia can be found in many different household products, such as Windex. Or, now that we've talked about the N2 plus H2 reaction, we're now going to talk about iron plus copper 2 sulfate. So this is the skeletal equation. So we have iron, copper sulfate, which reacts to iron, sulfate plus copper. Okay, so here we're now going to balance the chemical equation. So here I have the left side and the right side with all the elements labeled. We want to start, when we label, we want to start off with metals, then nonmetals, hydrogen, and then oxygen. We didn't need to do that for the first time because we only had nitrogen and hydrogen. So we first start off with the amount of irons. We have 1 iron, 1 copper, 1 sulfur, and see here 4 oxygen. So now we're going to come over to this side. We only have 1 iron, 1 copper, 1 sulfate, and 4 oxygen. So as we look, each side is already balanced, so we don't have to balance the chemical equation because it's already done for itself. Which means we have 1 iron, 1 bundle of copper sulfate. We then have 1 iron sulfate and 1 copper. So we now have a fully balanced chemical equation as it balanced itself already. We talked about balancing the chemical equation. Now we're going to talk about what type of reaction this is. This is called a single displacement reaction. Because as we look here, iron is a metal. We have copper, which is a metal, and sulfate, which is a non-metal. So as we look over here, we have 2 squares in a triangle. What single displacement is when you have 2 metals and 1 non-metal that switches places, which now forms to be iron sulfate plus copper. So the iron replaces the copper in its position, now showing iron sulfate plus copper. Now we're going to determine the final product of this reaction. So if we look at iron, it has a valence charge of +2. If you look at sulfate, it has a valence charge of -2. So these two will balance each other out. So as we look, we don't need to change anything. So when we come down here, because we only need 1 of each, we will need 1 iron and 1 sulfate.
Here we will be talking about similarities and differences between the 2 reactions. Some differences are, in reaction 1, it is a gas. In reaction 2, it is soluble in water. In reaction 1, synthesis occurs. In reaction 2, single displacement occurs. In reaction 1, it is used in a cleaning products. In reaction 2, it is a body mineral. Some similarities are, they are both a result of a chemical reaction. Large amounts of either substance can be harmful to the human body. Both can be found in food, such as meat or vitamins.
Now that we've discussed these 2 chemical reactions, I must be getting back to my mutation animals before it's too late. Oh no! It's a cat! Well, I guess I can always be an evil scientist. Is this a pretty good kitty stroke?
Universe was in a hot, dense state that nearly 14 million years ago expansion started. Wait.